All right, let's crack a classic coding interview question, unhappy friends. Now, the goal here isn't just about stumbling upon the right answer. It's about building a clean, super efficient, and repeatable strategy that's really going to impress any interviewer you talk to.
So, here's how we're going to tackle this. First, we'll make sure we actually get what the problem is asking. Then, we'll figure out our core strategy. After that, we'll build the tools we need, walk through an example, and finally, we'll analyze how good our solution is. This is the exact thought process you want to show in an interview.
First things first, let's really get a handle on what unhappy friends even means. Before we can dream of writing code, we have to translate the problem's rules into some really simple, clear logic. Let's make sure we're all on the same page. So here's the absolute key to this whole problem. For someone to be unhappy, the feeling has to be mutual. It's not enough for one person, let's call them X, to wish they were with someone else, you. That other person, you, also has to prefer X over their own partner. Both of those things have to be true. It's a two-way street.
Okay, so the input we get looks something like this. It's just a list of pairs telling us who's coupled up at the start. So friend 0 is with friend 1, and friend 2 is with friend 3. Our job is to investigate these partnerships and see if anyone's unhappy based on those rules we just talked about.
All right, we get the rules. We know what we're looking for. But how do we actually find it? I mean, we could just search through everyone's preference lists again and again, but that's going to be way too slow. For an interview, we need a much smarter, much faster way to do this.
And this brings us to a classic situation you'll see all the time in coding interviews, the time versus space trade-off. The brute force way means searching a list every single time we have a question, which is slow. The optimal way, we spend a little bit of memory upfront to pre-process the data. We build ourselves a lookup table. This gives us a massive speed advantage later, letting us get answers instantly in what we call O of 1 or constant time.
And really, this one sentence is everything. It's our North Star. The entire algorithm we're about to build is just a direct translation of this simple rule. If you can keep this in your head, the code practically writes itself.
All right, time to get our hands dirty. We're going to build a couple of helper data structures that will make the rest of this problem an absolute breeze. With these tools in place, checking for unhappiness becomes incredibly simple and, more importantly, super fast.
Tool number 1, the partner map. We need a super fast way to answer the question, who's your partner? A simple array is perfect for this. We just loop through the pairs once, and for each pair, x, y, we just say partner of x is y and partner of y is x. Done. Now we have instant O of 1 lookups.
Now, this next part, this is the real magic. This is the core trick of the whole problem. Instead of searching a long list to see who's preferred, we build a rank table. Think of it like a grid that gives us a preference score. For any person X, we can instantly find out how much they like person Y. A lower score means a higher preference. This is what turns a slow search into an instant lookup.
Okay, our tools are ready to go. We've got our partner map and our rank table. Now, let's walk through the main logic, step by step, exactly like you would for an interviewer, to show them you know your stuff.
Let's zoom in and check if friend 1 is unhappy. First question, who are they paired with? Easy. We just look at our partner map. A quick peek tells us partner 1 is friend 0. Simple as that.
Okay, so we know their partner is friend 0. Now we look at friend 1's own preference list, we just scan through it, and we stop at the first person who they like more than their partner, friend 0. In this case, that's friend 3. Let's call this person you. So condition number 1 is met. Friend 1 prefers someone else.
But here's the crucial second part. We know friend 1 likes you, but is the feeling mutual? Does you, that's friend 3, also like friend 1 more than their own partner? This is where our amazing rank table comes in. We can just ask it directly. Is the rank friend 3 gives to friend 1 lower than the rank they give to their own partner?
And thanks to our pre-computation, we don't have to search anything. It's an instant check. The table tells us friend 3's rank for friend 1 is 0, while their rank for their own partner is 2. Since 0 is less than 2, the condition is true. The feeling is mutual. Boom! Both conditions are met. Friend 1 is officially unhappy, so we count them and move on.
Look, getting the right answer is only half the battle in an interview. You absolutely have to be able to analyze your solution's performance. So let's talk about time and space complexity. How efficient is what we just built?
Let's break down the time it takes, where n is our number of friends. Building that first partner map, super fast, just one pass over the pairs, so it's O of n. But building that big rank table, that's an n by n operation, which is O of n squared. The main loop where we check everyone is also O of n squared in the worst case. So, the slowest part wins, which means our total time complexity is O of n squared.
And what about memory? Well, that partner map is small, just O of n space. But that big rank table is the main consumer here. It's an n by n grid, so it takes up O of n squared space. That means our total space complexity is also O of n squared, dominated by that lookup table.
So, what's the big idea you should walk away with? It's this powerful concept of pre-computation. You spend a little bit of time and memory up front to build a tool, in our case the rank table, and it makes the rest of your logic incredibly fast. Turning a slow, repetitive search into an instant lookup is an absolute game changer.
And this isn't just some one-off trick for a single problem. This rank table idea is a fundamental pattern. So the question to leave you with is, where else can you use this? What other kinds of problems could be totally cracked open by turning an ordered list into an instant ranking system? Keep an eye out for that pattern in your next interview.